Hey everybody, this is Chapter 8 and 9 Review, page 1. We went through this on our Zoom meeting, but since some people weren't able to make that meeting and also sometimes the sound was a little spotty, I wanted to go back through some of these that we covered and make sure you had a good resource to help you study for this. So the first 5 here on this page are going back to axiomatic system, what an axiomatic system is, talking about Euclid and his postulates, things like that. Now this stuff isn't as much in the book. This is kind of just stuff that I wanted to lay a foundation for you guys. So we watched that video, History of Math, and learned about those different mathematicians and things. That's kind of where this fit in the unit. But we talked about Euclid's 5 postulates, and I gave you a handout that had those written down on it. The 5th postulate is also called Euclid's parallel postulate. And what it says is if you have 2 lines, like we have here, M and N, intersected by what we call, this is called a transversal, when it goes across 2 lines like that. When we have 2 lines intersected by a 3rd line, we get these 2 angles. Now we're going to learn about this in the next chapter, but these angles are called co-interior angles. And what we know is if these 2 angles add up to 180, then these lines are parallel. And if these 2 angles don't add up to 180, then these lines will have to cross eventually. So that's what Euclid's 5th postulate says. It's about basically how can you tell if these 2 lines are parallel, if these 2 add up to 180. So this says, according to Euclid's 5th postulate, what can you say about lines M and N if the measure of angle 1 is 110 degrees and the measure of angle 2 is 70? Well, if this is 110 and this is 70, and I add them together, I get 180, which means that by Euclid's 5th postulate, these have to be parallel. And so what we could write is M is parallel to N. This is our parallel symbol. Or we could write it out in words. M is parallel to N. Remember that points usually are capital letters, and then lines are usually labeled with lowercase kind of scripty letters. So you can see these are kind of italicized there. Okay, Euclid's 4th postulate said that all right angles are congruent to each other. So that's kind of an obvious statement. If you have 2 right angles, they have to be congruent to each other. That's why it's a postulate. So this word is congruent. Okay, and Euclid's which of Euclid's 5 postulates would you be using if you used a compass to create a circle? Well, one of Euclid's postulates talks about using a point as a center of a circle and then a segment measurement as a radius of a circle to create a circle. So that's kind of how we do when we use a compass. We use a point and we use a certain distance and we do a circle. And that is actually Euclid's 3rd postulate. Okay. And then if you recall, postulate 1 and 2 are about segments and lines. So postulate 1 was that if you have 2 points, you can connect any 2 points with like a line segment. He doesn't say the word segment. But postulate 2 was that you can extend that line infinitely in any direction. So basically postulate 1, even though he doesn't say it, is about line segments, and postulate 2 is about lines extending infinitely. And he doesn't really always make the distinction between lines and line segments, and so that's kind of using some of our own kind of modern language to supplement what Euclid said. What is the name for new truths or rules or facts that are proven through logic and deductive reasoning? Okay, we usually call these theorems, okay, which we proved a couple of angle theorems this week. You can also call these propositions. That's what Euclid calls them. Theorems is more consistent with current mathematical language, though. So let's leave it actually as theorems, but if we wanted to, we could say in Euclid's Elements, he calls these things propositions. Okay, and what are the common notions or truths that are self-evident that do not have to be proven? In our current language, we call these postulates. Okay, Euclid called them either common notions, and sometimes you might hear them as axioms as well. Okay, but the way that modern mathematics works, theorems are things that you prove, postulates are things that are kind of obvious, or you just kind of, you don't have to prove them because they just kind of make sense. Okay, next we have this matching section. So these are all different things that describe angle relationships. So if you have two angles and they're complementary, what does that mean? If they're a linear pair, what does that mean? If they're congruent, what does that mean? And you can find a lot of these definitions in your book, and the best, there's a couple different sections that they're in, but 8.6 has a lot of these. So I'm going to pull this up really quick. Let's see if I can get this. So this is 8.6, the beginning of 8.6. So you got complementary, right? Two angles whose measures have a sum of 90 degrees. Supplementary, two angles whose measures have a sum of 180 degrees. You have adjacent angles. The way it describes adjacent angles is two angles that share a common vertex and a common side but have no common interior points. In other words, they don't overlap. So adjacent angles have to have the same vertex. They're basically touching each other. So this is like an example of adjacent angles right here, because this angle and this angle share AC as like a side, that ray AC. They both have that side, but they don't overlap. So that's what adjacent are. We got a couple other definitions. We talked about linear pair, okay, which is right here. So in a linear pair, the way that they describe in the book, in the official definition, is they're adjacent angles, but their non-common side forms opposite rays, right? So you have one ray going from here to here, and you have one ray going from here to here, and this would be like the common vertex. So angle 1 and angle 2 are two angles. They share this side right here, but the side that they don't share makes opposite pairs. In other words, when you put these two angles together, they form a straight line. Okay. Vertical angles has another kind of interesting definition. Vertical angles is two angles are vertical angles when their sides form two pairs of opposite rays. So if you look at these two angles, 4 and 5, you're like, okay, well this is an angle, and this is an angle, right? So the sides of this angle and the sides of this angle form two pairs of opposite rays, right? This one here and this one here. Okay, and then these two guys, their sides form opposite rays, because these guys here, they form these same opposite rays. So 4 and 5 are vertical angles. 3 and 6 are vertical angles. Basically, when two straight lines intersect, you're looking for angles that are across from each other, or basically non-adjacent angles from this pair. So these two are not adjacent because they don't share a common side. And so these are vertical angles, and then these are vertical angles. We also know from something that we proved recently, the vertical angles congruence theorem, that 4 has to be congruent to 5 and 3 has to be congruent to 6. Also over here on the linear pairs, we know that these have to be supplementary. So the measure of angle 2 plus the measure of angle 3 has to equal 180. And those are really important facts that you're going to use in your in some of these problems here on this assignment. Okay. Other things that we had in 8.5, just going back just a little bit, is congruent angles, right? Their measures are equal to each other. And there's just some other stuff in here that talks about, acute, right, obtuse, straight, things like that. Interior and exterior, and what those mean. So there's some other angle definitions in 8.5 as well. Okay, so let's jump back to this definition section and run through it. Okay, so the first one we want to find is complementary angles. Let's make ourselves a note that these add to 90. Okay, let's see if we can find one that said that looks like they add to 90. So two angles whose measure sum to 180. Nope. Angles have the same measure and do not necessarily share a vertex. Nope. They don't have to be the same to be complementary. Two angles whose sides form two pairs of opposite rays. That sounds like vertical angles. Two angles that share a common vertex and side but have no common interior points. That sounds like adjacent. Two angles whose non-common sides are opposite rays. That sounds like linear pair. There it is, 90. Okay, so the very last one. Two angles whose measure sum to 90 degrees. Okay, that's complementary. Okay. Cool, so supplementary would be two angles whose measures sum to 180 degrees. Also, an important idea is that if you have complementary and supplementary, they don't have to be touching. They don't have to share a common side. So I could have an angle that's like this, and let's say this is 40. And I can have an angle way over here somewhere, and we could say this is 140. Those are still supplementary even though they don't share a common side. So they're not necessarily adjacent. So this is, we're going to say A here. And that's the same with complementary. They don't have to be next to each other. They can be, but they don't have to be. Okay? All right, adjacent angles. Well, those are the ones, adjacent angles are when they share a common side. You put them next to each other, you kind of line them up next to each other, and they kind of share this common wall. So this is the divider between this angle and this angle, but they share that wall. So adjacent would be two angles who share a side, basically. Let's see. Two angles that share a common vertex and side, but no common interior points. Okay, so they have a common vertex, right? This angle, angle 1 and angle 2, they have the same vertex. But they don't overlap. That's what no common interior points means. It means there's nothing from this inside that's over here. So no overlap. So that's D. And since we're not going to use these more than once, we'll cross those out. Okay, vertical angles. So remember, vertical angles is what we get when we have two straight lines that intersect. So like these two guys would be vertical angles. And 3 and 4 here would be vertical angles. Okay, so we're looking for angles that when we put them together, we get two pairs of opposite rays. So here's a pair of opposite rays, and here's a pair of opposite rays. That's the official definition there. So two angles whose sides form two pairs of opposite rays. Okay, also a side note, two angles that are related in this way are congruent. Right, so if two angles are vertical angles, they're congruent to each other. So that's kind of a bonus. So C. Two angles whose sides form opposite rays. Also, P.S., they have to be congruent. That's vertical angles. Okay, linear pair. So linear pair is when we have two adjacent angles, but the two angles form a straight line, or in other words, a pair of opposite rays. So these are two angles, 1 and 2. This is the common side, the wall that they share, and then the other sides that aren't in common are opposite rays. So two angles whose non-common sides are opposite rays. Also, just a bonus fact here, two angles that are related in this way are supplementary. So we also know that if we add these together, the measurements, we should get 180 degrees. Okay, so that's E. Okay, and angles that have the same measure and do not necessarily share a vertex. Okay, so let's talk about some of the congruent things that we see here. Vertical angles have to be congruent, right? So if you look at this and you say, okay, angles that have the same measure. Well, you could say, well, vertical angles have the same measure, so that has to apply to vertical, right? But the thing about saying two angles are congruent is it says nothing about their orientation. It says nothing about like how they're oriented or positioned in relationship to each other. So what it's saying is they don't have to have the same vertex. You can have two congruent angles that don't even touch each other. Right? Something like this. So like 1 and 2, you could say 1 is congruent to 2, and those could be congruent angles. In vertical angles, 1 and 2 are congruent to each other, but notice they share a common vertex. Okay? So this is saying angles that have the same measure but don't necessarily have a common vertex. They don't have to be touching. So although vertical angles are congruent, and that's true, C is a better description for vertical angles, and B is a better description for congruent angles. Okay, so some of these overlap. Same thing with supplementary and linear pair, right? We know that linear pair, the two angles have to be supplementary, right? And so if we looked at linear pair and you're like, well, hold on a sec. Linear pair, these have to be supplementary. Two angles whose measure sum to 180. Cool, that is true for a linear pair. However, it says they're not necessarily adjacent. Okay, well then that's not linear pair, that's just supplementary. Linear pair, to be more specific, has these non-common sides or opposite rays. And then the bonus fact is, by the way, they have to be supplementary. Okay? So if two angles form a linear pair, they are supplementary. But just because they're supplementary doesn't mean they form a linear pair, because they don't have to be touching, like we drew a little bit earlier. If they're a linear pair, they do have to be touching and supplementary. If they're just supplementary, they just have to add up to 180. So be careful when you're going through these definitions, because it's easy to see, oh, they add to 180. Perfect. That goes with linear pair. Right? Well, that's true, but the rest of it isn't. So just be careful there. Okay, that's page 1. You can go back and you can check out those definitions and read those definitions if you need to. Also, I gave you a while ago a handout with Euclid's 5 postulates and things like that. So if you forgot that or you don't have it, this is a good refresher for that. Tune back into the next video. We're going to go over the next page for you.